So I want to welcome everybody. Today we quickly look at the logic of scientific reasoning. I usually start most of my sessions with some quotes just to stimulate our thinking. This is a quote from Jules Henry Poincare. He said, "Science is built up with facts as a house is with stones, but a collection of facts is no more a science than a heap of stone is a house." What you say in essence is that the knowledge that make up science or scientific knowledge are gotten through gathering of facts, but just gathering facts will not give you knowledge. Just like gathering stones, all those materials you use to build house, bringing them together will not make a house until you logically arrange them. So gathering facts without logically arranging the facts to bring out knowledge, you cannot have scientific. So knowledge is a function of logical arrangement of facts. So of course we get fact by going to the collecting data. That's what we mean by fact. That until we bring them together in a logical manner, you cannot know what is true or what is not true. Now, the purpose of science is to uncover the truth. What is true, what is not true. That is, to know what works in certain situations so that you can recommend. And if anybody apply the principle, the person will get result. And that is why Professor Osuala defined research as a process of arriving at a dependable solution to a problem through systematic collection, analysis, and interpretation of data. What I just want to emphasize there is dependable solution. So research may not even give you the solution, but it give you, not that as you carry out research, your problem is solved. It gives you solution that is recommended. If you now follow the steps, be able to get the appropriate result. So, and actually what the research is looking for, what is true, what works in certain situation and what do not work. And that was why Thomas Edison, after performing 1,000 experiments and he could not get light from electricity, he was not discouraged. He just told his co-workers that we just discovered 1,000 ways that will not work. So we can look for another way. So, science, research is about looking for what works and what do not work, so that we know what to do in certain situations and what to recommend in certain situations. So the purpose of science and research is to uncover the truth. Of course, we know that God Almighty knows the truth. It is we that we are trying to look for way to uncover so that we can make truth. And God give us the ability. And that is why one of the holy books says, what is hidden is for God. What is revealed is for us. So, and what is the process of looking for solution, God somehow revealed to us. And science is one of the ways, or not the major way. Now, the tools we use to uncover the truth. What are the truth? What are the tools? You will be surprised that if you go systematically, you know that it's very simple. Senses and ability to reason. Those are the tools. Those are the tools God has given to man to understand the environment. Senses, the 5 senses, the sight, hearing, feeling, taste, the touch, and smelling. Those 5 senses are what we use to perceive our environment. Then it's not just perceiving the environment, you must be able to reason. So when the senses give the impulse, reason with our brain. So ability to reason. And what does it entail? The reasoning is the domain of statistics. The reasoning, how do you, when you capture data, the facts, through the 5 senses. But what comes out through logical arrangement of those facts is your reasoning. And what statistics does is to help you to reason using the available facts or the available data. So there are 2 types of relationship between scientific mind, I mean the mind you use to reason, and the world. So you get the stimulus from the world, from the environment through the senses, then you now reason. And there are 2 types of relationship between the mind, the way you reason, and the world. You can see this, and I call it diagram of which are diagram. You can see observation. There's an arrow that goes to general theories. And from general theories, arrow goes to observation. The arrow that comes from observation to general theory, you see infer or induction. The one that goes from general theories to observation, you see predict or induction. That's the 2 types of relationship. And you get to know that it's also informed the type of.
Hello, sir. Good evening.
Okay. Hello.
Good evening.
Some people are not hearing.
George.
Is it that some people are not hearing?
Go ahead.
Yeah.
We're hearing.
Okay. When somebody's talking. Now, these 2
There's
types of
problem with network
between scientific mind and the world, induction and deduction, you get to know that even all the researches man conduct, either fall into this, by the time you conclude, your conclusion or your reasoning or your inference, get to know later, is generalization from the sample you take about the population. And the inferences you draw, the conclusion you make, follow any of these 2 patterns, either deduction or induction. Let's move further. What are the differences between induction and deduction, or deductive reasoning and inductive reasoning? In deductive reasoning or inference or generalization, because inference here, the word inference means generalization. So maybe I should just give the background. You know, a lot of things are interwoven in research and statistics, which you cannot actually completely unravel in one lecture. Inference just means generalization. And because as scientists or as a researcher, you are interested in what is happening in the population. But because of the cost, logistic reasoning and the cost, in some situation or in many situations when the population is infinite, that is unlimited, so it's difficult for a scientist or a researcher to attempt to take observation of all the elements in the population. For example, all the people maybe in a city or in a state where you are talking of maybe adult, like adult where you are having millions of people, it is quite difficult. So the researcher will take sample, which is a subset of the population. In as much as you have not taken the whole population, you take your observation from the sample, you cannot get the actual results. The actual results, you are looking for the summarization, you want to make the scope parameter in the population. While what you get by taking sample is statistic representing it. So the statistic is an estimate. The statistic without S now is not the subject. It only carries S if it is plural form. So the statistic is an estimate of the parameter. So by the time you finish, you need to make a generalization from the population, from the sample about the population. That is an inference. So we can say deductive reasoning or inference. In deductive reasoning, we hold a theory and based on it, we make a prediction of its consequence. E.g., we predict what the observation will be. That was the line of thought in those days. And it was thought that that was the only scientific method. And that is why in some books you still see scientific method. You make a guess. You say the guess is hypothesis. You make a guess and you now gather instrument to confirm if the guess is true. That was the only method believed to exist by that time. But it was later, if you look at this, what you have here, you see theory goes to hypothesis, then observation, confirmation, you confirm. If it is true, for example, let me use example that we may readily understand. You may say, oh, teenage pregnancy is as a result of socioeconomic status. Maybe you are just in a place in your clinic or anywhere you are in your office, and there are cases you have been handling of cases of teenage pregnancy, and you now realize that most of these cases are from lower class people. When maybe you see 10, you discover 8 or 9 are from lower class people. You now can make the conclusion. That is a spurious observation. You make an observation. What I just want to emphasize is the theory you have made. It's more like a guess. Oh, can the socioeconomic status be responsible for this teenage pregnancy? So for you to now test it, somebody have to conduct a research and have the hypothesis that socioeconomic status is the determinant of teenage pregnancy. And the conclusion will either be two ways, either true or false. And that is why you either prove it that yes, it's socioeconomic status that is responsible, or is not responsible. So that is the proving theory. The result goes. There are 2 possible ways. Either it is true, so you hold the theory in form of hypothesis, you prove it if it is true or not. So it was the belief in those days that as you continue carrying out research, maybe other people carry out the same research, find out that this particular theory is true. So it becomes principle after a while. And before if it continue, you continue proving it become law. That was the belief. It was later some scientists out came and said that even the observation you made is a form of scientific method. By just even that developing that theory, making that guess that socio-economic status may be responsible for teenage pregnancy. That also is a form of scientific method, and that is the realm of inductive inference. So in this inductive inference now, you go from specific to general. Specific means that there are some observations, just like the person that observed about 10 people or 20 people in his clinic or in his office, that he handled their cases and now realize that most of them that have these teenage pregnancies are from low socioeconomic background. So in making it general that socioeconomic status is responsible, or people of low socioeconomic status, the children will most likely have teenage pregnancy. You are generalizing. So it's going to touch anywhere, all over the world, wherever there is high and low socioeconomic group. You are saying that a teenage pregnancy will proliferate more among the low status. So from specific to general, that's induction. But the issue with induction is that it can be a form of control experiment, organized experiment, or it can be through spurious observation. The example I just gave now is spurious observation. In those days, they call something anecdotal evidence. Evidence when you just see one case like this, this case, you have never seen anything like this, and you see this is related to this. And then it's still part of spurious observation. But many people didn't believe before. It was later people got to know. You most of us, we that are doctors, we know that Galen was the greatest physician of antiquity after Hippocrates. He declared that blood was produced in the liver for 400 years. People believe that. No deviation, no objection, until people later discover that blood was produced in the bone marrow. So you see, that is, the example was an anecdotal evidence by an expert, so-called, maybe somebody that believed to be an expert, or somebody that has practiced for 50 years or 60 years. It's an authority. It doesn't make it a statement. I would believe it's an anecdotal evidence. It doesn't leave me. You can live, even if you live 100 years and practice 100 years, it is not possible for you to see all possible cases, even as a doctor, even in any field. You live for, even as Methuselah, you may not be able to see all possible cases. And that is why statistics is taking prominent position in research. Whatever anybody say now, you try to say, okay, what is the validity? So you can see how you can differentiate between inductive inference and deductive inference. So you can see from here that inductive inference generates theory, hypothesis. It's not all study that tests hypothesis. Most of the time when you do descriptive study, it doesn't test hypothesis, it rather generates hypothesis. For example, somebody say, pattern of driving in Abuja, pattern of driving. Want to study pattern of driving? There's not. You just feel that you should try pattern of driving. Just look for something. Just study it. So there's no theory. He will not be holding any theory in mind that this won't cause accident or not. Just pattern of driving. Of course, he has to get literature, then design questionnaire to capture many variables, the license, age. When did you start driving? Have you had an accident before? Has anybody hit you before? Many questions. Then you capture the sex and many things. If the person has driving license, has gone to driving school or not. Those are the things you capture. At the end of the day, that is a descriptive study. At the end of the day, you begin to see pattern. The pattern you see is that, oh, you that didn't go to driving school are more likely to have accident. In younger age group, maybe less than 18 or less than 20 people are more likely to have accident. Maybe ladies, female are more likely to have accident. You list a lot of, these are theories you are generating. So you can see a descriptive study most of the time will not generate hypothesis. Because when you want to test the theory is in form of hypothesis. So the generalization you're going to make at the end of the study is inductive inference. Oh, female are more likely to have accident than male. So it's a generalization. You only take sample of 150 in Abuja and you are generalizing that female in Abuja are more likely to have accident more than male. Or you're underage, or maybe anybody less than 20 are more likely to hit another person. These are theories generated from descriptive study. Then, so the conclusion you make, female are more likely to have is a generalization. It's an inductive inference. In the sense that is from observation, you are making that general theory because you are giving the general theory. The conclusion is that female are more likely we have accident more than male. That is inductive inference. But another person can take up your work, maybe after reading your checking literature to stand out your work. Oh, it has been published that females are more likely to have accident. In that case, this person can now do, okay, he's holding that theory, you want to test it. And now sample male and female, and now try to find out the rate of accident between the two separate. Yeah. It doesn't have to be experimental study. So when you now have analytical study, if you really want to study, you have to sample male and female separately, and try to see the rate of accident among them. The conclusion will be either it is true that female are more likely to have accident or not. It may be false. So the generalization you're going to make now is called a deductive inference, because you started with theory, you end with observation. You started with theory, you now want to carry out observation. So it's a general theory. You now sample. That sample is more specific that you cannot even study the whole people anyway. You now take some and now study to see if it's true or not. So that is why you will see, say, okay, let me go back to that first slide. Say, deduction is from general theory, from observation to general theory. Deduction is from general theory to observation. So just to throw more light, in deduction, you hold a theory, you present it in the form of hypothesis, you carry out observation, means you collect data. That's what the observation just means. You collect data and confirm. You confirm. When you confirm, it may be true, it may be false. Then for induction, it's observation is not so made. It can be spurious observation. It can be like you want to just sit down and see it's spurious observation in your clinic. Like is it Newton that just saw that no fruits just dropped? It was an observation. He made an observation that a fruit drop. What caused? There must be a force that draws the fruits down rather than sideways or upward. There must be a force that is directed downward. That conclusion was an inductive inference. But later, they now perform a lot of experiments to prove if it is true or not. That was how they discovered the gravitational law. Can you see? Both of them are scientific method. It was believed before that it was only deduction that you have to do. Even within theory, it takes somebody that has scientific mind also to just make an observation and make something from it. That's, some people say that if it were to be another person, they just carry this fruit and eat the fruit and just go. But he was able to reason. That was a scientific method also, that is induction. That was an induction, then deduction, induction. So you see that the science or the knowledge increases by interplay of inductive reasoning and deductive reasoning. You remember when you had the first case of HIV in Lagos, in Nigeria, was in one 60-year-old girl in 1986 in Lagos. I'm sure maybe the doctor or the health worker that saw the patient, maybe they will have gone to Geneva, travel out to go and present one case report. Because it was real, that was the first case. So that one case was an epidemic then. So later, when the thing became commoner, you will now be talking of case series report. You can have 10 cases, you will try to describe them. Later, you are like anything. Maybe that was what the coronavirus will become. So it's like every other thing everywhere. So you can now say you are doing descriptive study. No, you knowledge and attitude, you want to differentiate those who have it and from those who don't have it. By that time, there was no way you would do experimental design or analytical study. But later, as generative people started generating, scientists started generating a lot of hypotheses from descriptive study on HIV. Later, you now have a lot of literature that are full of theories. So people now started testing. Is it true that this is it? That women are more likely to have HIV more than men? No. You prove it either right or wrong. That one would be deduction. So can you see interplay? So the type of study you do or the conclusion you make depends on the stage of the problem in the society. So it's sometimes when people say that you just have to do experimental design by force, by fire. No, you first of all the step in doing research is called know the problem statement. When you know the problem statement, You now look for the best way at the stage of that problem, the best of that condition, the best way to study. For example, many randomized control trial has proven that low dose aspirin prevent death from cardiovascular disease. Yes, it was confirmed by many trial and even meta-analysis. Physicians started prescribing low dose aspirin to patients with heart disease without following up. It was experimental design they used to do that, without following up with descriptive study, with observational study. That those people that are taking aspirin, what happened to them? Because when in experimental design, what you actually get is the efficacy of the drug, not the effectiveness. Because effectiveness is you can only get that in the real life. But in under control experiment, it's efficacy because you have a lot of excluding criteria. Like for so you may say, okay, for a particular drug, you exclude epilepsy, diabetes, hypertensive, and many sickle cell. You exclude a lot of people from taking part because of the effect it may have for them or they may have on the result. But in real life, someone that is having epilepsy may have heart disease and need that particular drug. The person that is a sickler may have heart disease. The person that is pregnant may have heart disease and many things like that. So in the real life, there is the effectiveness, but in the control experiment is efficacy. And after prescribing the drug, it is good to carry out observational study to really know the effect on people. And that one can be more even difficult than the experimental design. It can be more difficult and more costly. So I think we can see that knowledge increases by interplay of these two scientific reasoning, and no one is superior to the other. Now, let's quickly look at the problem of error in inherent variability of natural phenomena. Now, in studying phenomena in the population, we have problem of error and inherent variability. We are not talking about the error of measurement now, because if they don't have potential error measurement, we know that there are different biological variability is one of the causes of error. Now, theory can be used to predict observation, but observations are not always exactly as we predicted. We have already talked about how we can use theory to predict observation and now come out with deductive inference. But how we predict is sometimes it may not come out. Not coming out may not be because it is not true, but it may be because of some error due to some inherent variability in the phenomenon you study. If the observations are widely different from the prediction, the theories have to be abandoned or modified. Of course, yes. How do we differentiate now the discordance between our prediction and the observation from the discordance due to error and inherent variability? How do you know that it is not that when you cannot, maybe you cannot prove, your theory, you cannot prove it right? How do you know if it was because of inherent variability, error due to inherent variability, not because that particular theory is not true? It is by carrying out statistical tests. Now, let's look at how it works. Variability of phenomena is the need for statistical analysis. It's because of that variability of phenomena. Behaviors of phenomena explained by using model. You can use model to explain real life situation. There are two types of this model. We have deterministic and probabilistic. The probability is also called stochastic. A phenomenon is said to be principally based on deterministic model if when the guiding theory or law is tested, the same result occurs. Now, there are some situations where irrespective of location. When you carry out the experiment, it's all usually giving you the same result. And this one is common in chemistry and physics. Like water, what the composition of water, what constitutes water, we know that it's made up of hydrogen and oxygen. Carry out the results, the experiment in Toronto, come to Otukpo in Nigeria to do it, it gives you the same result. Go to another place to do it, it gives you the same result. If you can't have the same result, maybe you didn't follow the same method. Those phenomena, like in chemistry, natural science like chemistry and physics, most of them follow deterministic model. But it's not like that when it comes to biology. Even though biology is a natural science also, there's life science, biology, and social science. Most phenomena follow probabilistic model. Okay, before we get there, example of these phenomena that follow deterministic model. You remember in physics and chemistry, Boyle's law, Charles' law, talk about volume and temperature, pressure. Boyle's law talk about pressure and volume. They are inversely proportional. Do it, perform the experiment. It's always the same everywhere. It's the same principle. Pressure and volume are inversely proportional in Nigeria and as in London. The same thing with Charles' law. The temperature and pressure. The temperature increases, pressure increases. It's the same thing anywhere in the world. But let's talk about discrimination against HIV patients. Is it the same in Nigeria and America? It's not the same. These are social science issues, behavioral science issues. Also, if you measure your blood sugar now and take, even in succession within 1 minute interval, take the blood sugar again and measure, you won't get the same result. And measure your blood pressure now, you can, even after 1 minute, you won't get the same result. Even inside the body, the biological variables vary. It's constantly changing. So you see the biological and social science, when I say biological, including medicine, life science, social science, phenomena, they are influenced by factors, many factors within themselves. Even within themselves, there are variable factors that you cannot even identify. And that is why if you try to prove a theory, concerning variable, biological and social science variable, if care is not taken, you may end up, maybe saying that it's true when it is not true, or it's false when it is not false. If you don't control for a lot of variable factors that may influence. So there are some variability. So the situation where the model is principally probabilistic, statistical techniques are needed to increase scientific knowledge. However, even though we said that in some fields, most of the phenomena follow deterministic model. Well, maybe at the physical level, at the subcellular level, we know that kinetic theory of matter is in a state of constant motion, even within, inside the atom, even in your body, the atom that make up, they are moving, they are vibrating. So that was why, if you remember the uncertainty principle also, most of the things we even thought follow deterministic model. Later, people get to know that they also follow the level of probabilistic, or stochastic in those, in their properties also. So you see that in many fields also, it's not only biology and social science that needs statistics, but over the years, the contribution to statistical knowledge has been made by life scientists and social scientists more than all those in chemistry and physics. even though they need it also. Because the science, life science, science and social science need statistics more because of the variability is more. So that one compare the the scientists in those fields to contribute more to statistics. We've heard of Fisher. Fisher was a geneticist. All these Pearson, Spearman, Pearson that invented first of all described chi-square. Spearman, Pearson also described the Pearson correlation. Spearman also that talked about Spearman correlation. Though Fisher was the one that wrote statistical table. All those people were biologists. We also have some social scientists that contributed enormously to statistics. But we have some natural science chemists or other people that but most of the people that developed statistics in history were biologists and social science. In other words, the presence of variation requires the use of statistical analysis. Just to explain further, deterministic versus probabilistic model. No deterministic contain no random variable, well, that's the assumption, but we know that to a certain extent, not as random as probabilistic. As you know, set of input that will result in unique set of output, you can predict that this is the result. You carry out the experiment very well, so the repeatability is higher. Then stochastic or probabilistic has one or more random variables. Random input lead to random output. Random output only estimate of the true characteristics of the system. Even when you get the result is still an estimate. You know that you are not even sure if it's actually the result, but it's still an estimate. Good to know. You get to know that. If you remember when we discussed parameter and statistics, statistics is an estimate of parameter. So statistics is the technology of scientific method. How? Statistical methods are objective methods by which group trends are abstracted from observation of many separate individuals. When I say individual, it may not mean human being alone. Separate subjects can be house, can be animal, can be horses, can be stars. More often than not, the researcher is not able to carry out observation on all the units constituting a population for cost and logistic reasons, which I said before. So the scientists have to conduct the research by observing subsets of the population, which is the sample, and now extrapolate and make an inference. So now generalize. Generalization is now made from the small sample, the sample about the population is the inference. And we have talked about the deductive and inductive inference. The reliability of such inference or conclusion may be evaluated in terms of probability statement. It's different from the probabilistic model. That is where probability comes in statistics. So probability is in the heart of statistics. In fact, statistical thinking starts with probability and ends with probability. Because in statistical reasoning, we make inductive inference from the specific, from the sample, to the general population. Statistics may be referred to as the technology of scientific method. Statistics are referred to it as the technology of scientific. How? Even the astronomers that study stars, that study planetary body, even when if they want to know the distance between two planetary bodies, they should try to use their telescope. They take measurement many times and now calculate the average. Even the people in the laboratory in any scientific endeavor, when they take of the measurement, they take measurement many times to calculate because they are not sure because of the error to reduce error. They take measurement and calculate the average, believing that average will be close to the parameter, the rating they are looking for. So before they can make valid conclusion, before any scientific method, before any scientist can make any valid conclusion in any experiment that has been performed, or any research work, statistics will be involved. And that is why statistics is the technology of science. So I think we stop here to entertain question. I know that you have question. Yes. Question. If you have, you can chat your question. If you don't want to ask the question directly. And I will just read the question. I will not mention your name. I will answer it. So you can chat. If you want to ask your question, you are free. So you unmute yourself. You ask the question. I respond. Let me see. It's only one chat.
Sorry, sir. Thank you
Okay,
very much.
Yeah.
Thank you very much, sir, for the lecture.
Okay.
So my question is still tied to the deductive and then the inductive.
Yes.
You know, you mentioned that the deductive, you start from theory.
Yes.
You now go down to confirmation. While for the other one, you start from observation. So does it mean that in the inductive, you have to, is that where you are now doing those experiments? That is, either the experiment could start from cases, case reports. Is that what the observation means?
Thank you. Observation just means data collection. Observation just means data collection. And if you remember, I say you use your senses and your reasoning faculty. What do you use to collect data is the senses. If you are collecting data now, even the normal research you yourself you do. Oh, you want to ask me?
Sir.
You need to ask me if I'm a man of a woman. Unless if you are interested in sex, in gender. Gender is different from sex. If you want to, you can see a man that is the wife of another person, in that case, a female, that was gender sexual orientation. But by looking at me, you will not likely ask me if I'm male or female. You just tick me. By looking, you have used your eyes to you can see, right? If you want to know my skin, if you want to capture my skin color, you know if I'm dark or I'm whatever. Even you as a doctor, if you are collecting them, maybe if you want to see pallor, you use your eye to see all those things. But there's something you use your hand to feel. You palpate. When you palpate, you are trying to check, figure. You use your senses to collect data. Observation means you are collecting data. That's all. Even if you are somebody start on weighing scale, for you to read and say this person weighs 70 kg, you have to use your eyes to see it. Some people you may have to taste. All these people that do audition, you may have to taste some things to know, But what I'm just saying is that observation means you use your senses, and that is the observation we talk about there, collecting data. So somebody that just sit down and say, in the clinic, and now, the example I gave, I said that, I discovered that most of these people that are having teenage pregnancy, these cases of teenage pregnancy are from this sector of the community. It's an observation. The person, even though it's a spurious one, yes, I mean, it's a spurious observation. It's an observation. He has collected data because he will tell you that I've seen about 20 in the last 3 months, and out of the 20, can you see 18 of them are from low socioeconomic class? He has collected data. It's observation.
Okay, sir. So then the next step, yes, sir. Okay.
Yes.
Then the next step after that observation, is that where you now do the different levels of experiment to now eventually lead to theory?
Okay, thank you. The theory, when you are, your mind is still in those things they taught us in those days that if you have to perform experiment, you have to do that. You yourself, you're a public person, you know that experiment doesn't have to be in laboratory. Experiment in research means that we are influencing the phenomenon you are studying. You do something to even by giving education, you are performing experiment in research, right? So experiment in the laboratory also is part of it. But the experiment the word experiment in research is different from the experiment in laboratory. Can you see now? Now, when you say observation, you collected data. When you collect data, you analyze. So you now come out and conclude. But if you look at even if in deduction also, you collect data also. But what we are saying is that in induction, when you collect your data either in a spurious way or in spurious way or in a particular study, like for example, I say pattern of driving. I've collected, it's a study, pattern of driving. And then the day I begin to say, oh, younger people are more likely to have accident. That's a theory I'm making. To the extent that if somebody has to say, is it a youngster? Is it a young person? Because some people have already said that most of younger people, you will likely have accident. When they now say, is it a young person? Or maybe aged people are more likely to have accident. Then you see how old is the person? You want to know. Because there's a general theory that is revealing that, oh, younger people will have accident. Can you see now from observation, you have generated a story. But in a study where you have done literature review, you are holding that type of theory in mind. You are saying, oh, it has been published that so is linked with this. That type of study you are testing an hypothesis, you are testing theory, you are testing that theory. If it is true or not. In try to tell you hold the theory, you still go and collect data. That is why they say you are moving from theory, general theory to observation. Observation means you are collecting data. That is deduction. Whereas in induction, you are moving from observation you are made to give out theory. Does it make sense? It's just logical.
It now makes sense. So does that mean that what we do is deduction?
When you deduction, what you do if your study was you had an hypothesis before, you have something like your own study, an analytical study. You have an hypothesis that maybe the location, either urban, rural location, affect the drug substance use. That's a theory.
Yes.
You are proving, you want to prove it right or wrong. If I tell you finish your research, if you now find that people from a particular location take drug more, that shows that the theory is correct, that your location, either urban or rural, has influence on whether you take substance or not. That particular generalization you are making, because you are talking to the population, but you only took sample. It's not the whole population you study. You are making generalization. But that type of generalization, because you prove a theory right, is a deduction. Even when you prove it wrong, also it's a deduction. You are making deductive inference. That is deductive generalization. But if, let's say, your study was you just do descriptive, you did the descriptive study, you now find out these people that are in rural something, they are more likely to you do your cross tabulation. You now find out that the people in a particular location, maybe rural settlement, take drug more, or people in urban city or in slum take drug more, substance more than the other people. You are generating theory, because that was not what led you to the study. You are just talking about substance use generally. That's a descriptive study. And you now come out with some observation, with some theory, hypothesis, and then when you now say, oh, this one is statistically significant. There's an association between this and this. From your descriptive study, you are generating theory. I think you've gotten it now.
Yes, sir.
Have you gotten it?
Thank you, sir.
Yeah, welcome.
Yes, sir.
Any other one? Any other question?
My network was off when you were making a distinction between deterministic and the probabilistic phenomena. I've been battling.
Okay.
I've been battling.
The one I'm just saying, I was just talking of is that the behavior is just talking about the degree of variability in a particular phenomenon. If a particular phenomenon does not vary much or doesn't even vary, but they hardly vary, it is believed that it follows deterministic just from the word. You can predict it very well. You can determine, oh, if I perform the experiment, and if you perform the same thing anywhere in any location and follow my procedure, I can be sure that you get the same result. That is deterministic model. Like most of the experiment, most of the phenomena in physics and chemistry follow like gravitational law, Boyle's law, Sharp's law. That is why they remain that law forever, because every time anybody performs the experiment, you get the results predictable. But it's not like that in biology and in social science. Behavior change even over time, like discrimination against HIV. Even although some of the social issue we have in our environment, even within Nigeria, it's not the same thing that you see in Abia that you see in Sokoto. They are different. Even if you talk about HIV discrimination, it's not the same thing in Otukpo and Ibadan. Even within Ibadan, it's not the same thing within, different quarters in Ibadan. So because that type of phenomenon vary a lot. And I gave an example, even your blood sugar, if you take your blood sugar after one minute now, take different blood sugar, one minute interval, take 10 of them, you may not get the same result. Because even within you, everything vary, even your blood pressure, they measure it. If they put you on this in measuring somebody's blood pressure continuously, it will be fluctuating because it's changing. Because it varies. That's called biological variability. So most of those biological variables and social science variables, because of that behavior, they vary a lot. They say they follow probabilistic or stochastic model, as opposed to the others one that are fixed in their behavior that follow deterministic model. I think it's clearer, sir. Is it clearer? Is it clearer? Prof. Okay. Any other one? Any other question? Any other question? Dr. Balashe, well done. Any other question? Okay, it's very straightforward. Because when you don't have question like that, it's either it's very straightforward, well explicit, or it is confusing. So which one? I'm sure it's not confusing. Okay, I think we stop there. And let me pause the recording so that to be included. If your number is not on the WhatsApp group, you can share the number to me. You can share it privately to me, or you send it to my phone so that I can be you'll be able to have access to all the information I usually disseminate. Thank you, everybody.
All right, thank you, sir. Good night, sir.
Thank you, Prof. Well done, sir.
Thank you.
Welcome, sir.